Electric vehicles are completely changing the way we think about getting around. They're sleek, they're quiet, and they're paving the way for a cleaner future. But behind every single one of these revolutionary cars lies a silent and very significant challenge: the battery. For decades, lithium-ion cells have been the workhorse, powering everything from our phones to our cars. They've served us well, but their time might be coming to an end. A new contender is stepping into the ring, one that promises to be the next giant leap in clean energy. We're talking about solid-state batteries. So, what's the big deal? Why do we need something new? Well, the current lithium-ion batteries that power virtually every EV on the road today use a liquid electrolyte. And while they're incredibly efficient, they are far from perfect. One of the biggest concerns is safety. This liquid can be flammable, and under certain conditions, it can lead to overheating, a phenomenon known as thermal runaway. You've probably heard stories about battery fires, and this is often the culprit. Beyond safety, there's the issue of degradation. Just like the battery in your phone, an EV battery loses capacity over time with every charge and discharge cycle. This means its range gradually decreases over its lifespan. Then there's the limitation on how much energy they can actually store. We all want our EVs to go further on a single charge, but there's a physical limit to the energy density of current lithium-ion technology. Pushing it further often means compromising on safety or lifespan, and let's not forget charging times. We live in a fast-paced world, and waiting for hours for your car to recharge can be a real point of frustration for many drivers. We want more range, we want our cars to charge in minutes, not hours, and above all, we want them to be fundamentally safer. These demands are exactly what's fueling the intense, global race to develop a better battery. This is where solid-state batteries come in, and they are a true game-changer. The core innovation is brilliantly simple in concept. They replace that volatile liquid electrolyte with a solid one. This one, single change, completely transforms the battery's performance and characteristics. First and foremost, it drastically improves safety. By removing the flammable liquid, the risk of fire is virtually eliminated. You get a much more stable and robust power source, but the benefits don't stop there. Solid-state designs allow for a much higher energy density. This means you can pack more power into the same amount of space, or make the battery smaller and lighter while keeping the same range. Imagine an electric car that could comfortably drive 1,000 kilometers, that's over 600 miles, on a single charge. Or picture plugging in your phone and having it fully charged in the time it takes to make a cup of coffee. This isn't science fiction, it's the potential that solid-state technology unlocks. So, how do they actually work? Let's dive into the science. In any battery, you have ions, charged particles that move from one electrode to another, creating an electrical current. In a solid-state battery, these lithium ions travel through a solid material instead of a liquid. This solid electrolyte can be made from various materials like advanced ceramics, sulfides, or specialized polymers. One of the most critical advantages of this solid structure is its ability to prevent something called dendrite growth. Dendrites are tiny, sharp, tree-like structures of lithium metal that can grow inside a liquid electrolyte battery over time. If they grow long enough to connect the two electrodes, they cause a short circuit, which can lead to failure or even a fire. The solid electrolyte acts as a physical barrier, blocking these dendrites from forming. The result is a battery that is not only safer, but also lasts much longer because it is not susceptible to this primary mode of degradation. It's a more stable, more compact, and fundamentally more durable energy cell. The race to commercialize this technology is on, and the players are some of the biggest names in the automotive and tech industries. Companies like Toyota, Samsung, and innovative startups like QuantumScape are pouring billions of dollars into research and development. They know that whoever cracks the code for mass-produced solid-state batteries will have a massive competitive advantage. Toyota, a longtime pioneer in hybrid technology, has been particularly vocal about its ambitions. They've promised to unveil electric vehicles powered by these next-generation batteries within this decade. Their goals are audacious: charging times of 10 minutes or less, significantly longer battery life, and a safety profile that offers drivers complete peace of mind with zero fire risk. It's a high-stakes competition, and the laboratories of these companies are buzzing with activity as scientists and engineers work tirelessly to turn these prototypes into a commercial reality. Beyond just making our cars better, solid-state batteries have a profound environmental story to tell. They aren't just more efficient, they are designed to be more eco-friendly from the ground up. The manufacturing process can potentially use fewer toxic and rare materials compared to some current battery chemistries. More importantly, their significantly longer lifespan means they won't need to be replaced as often. This directly translates to less manufacturing, less mining, and less waste heading to recycling facilities or, worse, landfills. This extended durability is a crucial step towards a truly circular economy for batteries. When you combine this with the global shift to renewable energy sources like solar and wind, the picture becomes clear. We can imagine a clean, sustainable future where everything, our cars, our delivery drones, and even our homes runs on safe, reliable, solid energy. Of course, this revolutionary future won't arrive overnight. Like any groundbreaking innovation, there are still significant challenges to overcome. The biggest hurdle right now is cost. The advanced materials and precision manufacturing processes required to make solid-state batteries are currently very expensive. Bringing that cost down to a level competitive with today's lithium-ion batteries is the primary focus. Scaling up production from laboratory prototypes to millions of units for the global market is another complex puzzle. Scientists are also working to perfect the long-term durability and performance of these solid electrolytes under real-world driving conditions through freezing winters and scorching summers. These are the final hurdles, the last pieces of the puzzle that need to be solved before solid-state batteries can truly power the world. Despite the challenges, the path forward is clear, and the momentum is unstoppable. The potential of solid-state technology extends far beyond just electric cars. Think about aviation, where lighter, more powerful batteries could enable electric airplanes. Or space travel, where reliability and energy density are paramount. Think about medical devices, consumer electronics, and large-scale energy storage for our power grids. This technology will redefine how we store and use energy across nearly every sector of our lives. This isn't just a simple evolution from one battery type to another. It's a fundamental energy revolution. The future of electric mobility, and indeed our energy future as a whole, is solid. Thanks for watching. If you found this look into the future of battery tech exciting, don't forget to hit that like button, subscribe to the channel, and ring the bell so you don't miss our next video. We'd love to hear your thoughts in the comments below.